So yesterday we learned a lot of methods by which you can solve or by which you can find the derivatives of given functions. So today we're just going to be applying those same methods. We learned about the quotient, the chains, the product. Yeah, we learned about those methods. So without wasting much time, let us begin. Yeah, so when you look at this first question here, this one is straightforward. You just use the property of this E. Yeah, you use the property of this E. We know that when you're differentiating this, if when you're differentiating this question here to find f prime, so to find f prime of x is just the same as the f of x dx, which is just in other words dy dx. So f prime of x is equal to, you differentiate the power. So when you differentiate the power using the power rule, you're going to get -2, because you know that this 2 is a constant, and then this, when you differentiate the 2, you just remain with a 0. Then when you differentiate -2x, you get -2. Then after differentiating that, you write back the same function this side. So that is how you differentiate the E. So these questions are just as simple as this. It's done. We're done with this question. We move on to the next question, this one. So for this one again, still the same. To find f prime of x, you also just have to differentiate the power and then multiply it with the whole function again, since we are still dealing with this E. So that's what you do. You first you first differentiate the power and then multiply it with the whole function. Yeah, if you want, you can be following the steps of chains rule. You still get the same answer. And then here, so we differentiate the power. So we first start by differentiating 2 sine x. When you differentiate 2 sine x, you're going to get 2 cos x. And then when you differentiate this part, which is cos 3x, using chains rule, you get 3. Sorry, you're going to get a negative. When you differentiate cos, you get negative sign. That's the way it is. So we're going to get -3 sine 3x. So what you do when you're differentiating a trig function with a function here, you differentiate the function. So like in this case, what I did was I differentiated 3x and then I got 3. This is the 3 I wrote there. And then after differentiating the function, and then you differentiate the trig ratio. So the differential or the differentiation of cos theta is negative sine theta, which I've just written there. Yeah, so after differentiating all this, you write your E and put back everything again. So you're going to have 2 sine x, then plus cos 3x. This is how you differentiate E. So it's just as simple as this as well. You don't need to do a lot of things. If you want, even on this question, you can use chains rule, you still get the same answer. So we proceed. When you look at this question here, see, this question there is, we can see that we have two functions which are dividing themselves. So remember what we said, when you're dividing two numbers, the answer that you get is the quotient. So meaning in this equation, we're going to use quotient rule solve, to find f prime. So f prime using quotient rule, f prime is given by, so f prime of x will be given by v u prime minus u v prime, then everything divided by v squared. So in this case, what we need to do is to identify which one is your v, which one is your u. And then in quotient rule, for product rule, you can choose any of the two functions, and you can choose any of the two functions to be either u or v. But for this one, v is always the denominator. For quotient rule, v is always the denominator. So our u will be the numerator there. We say u is equal to e to the power x minus e to the power negative x. And then you find your v. Let me do this. You find your v again, which is the denominator there, which is just e to the power x, then plus e to the power negative x. So you find u prime there, which is just the derivative of that function. So when you differentiate this, you still get the same thing, ex. When you differentiate ex, you still get ex. That's how it is. Yeah. So when you differentiate ex, you still get the same ex. And then when you differentiate negative ex to the power negative x, so we differentiate the power there. When you differentiate negative x, you get negative 1. So negative 1 times the coefficient, which is negative 1 this side, you get positive 1. Remember what we were doing on this one. You differentiate the power and then multiply everything with the whole function. So we differentiate the power here, we get negative 1, and then multiply it with the whole function here, we'll get a positive there. Positive e to the power negative x. And then to find v prime, you are going to get, when you differentiate ex, you still get the same ex. Because when you differentiate x, you get positive 1. Positive 1 times ex, you still get ex. It doesn't change. Plus, oh sorry, it will not be plus here. Instead, it will be minus, because when you differentiate negative ex here, the power, you get a negative 1. Negative 1 times ex to the power negative x, you get the same ex. E to the power negative x. Yeah, you get a negative. So here is just a matter of plugging them in the formula. So we write our v there. Our v is ex plus e to the power negative x. You put them in brackets, and then you write your e prime, your u prime. We're following this equation. So my u prime there is e to the power x plus e to the power negative x. You close the brackets, and then minus, you write your v. You write your u, which is e x minus e to the power negative x, and then everything divided. Oh, sorry, we write our v prime this side. Our v prime is ex minus e to the power negative x, like that. Then here, so what we're going to do is we divide by v squared. So my v is just this part here. So v is e x plus e to the power negative x, and then we square it. So let me just do this. Okay, so we now simplify this to this times that is just this same thing squared. So we're going to have ax plus e to the power negative x, and then we square this. Then we say minus, even this side we just square those since they are just the same, minus e to the power negative x, and then you square them. Then everything divided by e x plus e to the power negative x, then you square them like that. So here, if you want, you can simplify it further than this. If you want, you can leave it like this. There's no problem. Yeah. So we move on to the next question. Since we are just having one session today, at least we should be done with question 6. If possible, we should also be done with question 7, since it's just a single question. So we proceed. This question here, as we have just been discussing in these previous questions, you can see that we are still dealing with E. Yeah, we are still dealing with E.
The previous question.
Huh?
What's the final answer for the previous question?
The previous question, the one that I wrote just there, down. You didn't see it. Okay, let's proceed. Okay, I'll send the solution for this question for your sake. I'll send the solution for this question. Let's just finish the question. So, actually, I'm going to send the video, so we are going to see it. Okay, so we proceed to this question. So f of x is equal to that, meaning finding f prime of x is going to be equal to e to the power 2x. You differentiate this, so meaning you're going to differentiate the power there. When you differentiate the power, you get 2. The derivative of 2x, you get 2, and then multiply with the whole function to e to the power 2x, and then plus. Even here, you differentiate the power there. But remember, when you're differentiating the power, this power is a product of two functions. So you're going to use product rule to differentiate that. So how do you differentiate using product rule? You say, you write first x. I'm differentiating the power there. So I'm going to write first this x here. I'm going to write the first x here, which is this one here. So I'll write that x, and then multiply it with the derivative of ln x. The derivative of ln x is just 1 over x, and then I'll say plus, you write ln x, and you just write this. So ln x, and then multiply it with the derivative of x. The derivative of x is just 1. So multiply ln x with 1, you still get ln x. So that is the derivative of that power, and then multiply by e to the power, the same function, x ln x. I don't know why I keep on writing this I here. So we proceed. So we're going to have our f prime being equal to, this is 2e to the power 2x. Then when you simplify this, you're going to just have plus open brackets, and then you're going to have x times 1 over x, you get 1, and then plus ln x, plus ln x, yeah. let me just write this plus ln x and then multiply by e to the power x ln x. So this is the final answer for this question. Just in case you forget to see it again, this is the final answer for this question. So we proceed to the next question. So the next question is f of x is equal to 6 to the power 5x. But I think for this question, for us to be using f of x, it's going to be, it's we're going to be writing a lot of things. So instead, I'm going to say, let f of x for this question. So I'll say let f of x be equal to y. So while there is f of x, I'm going to be putting y. So I'm going to have y is equal to 6 to the power 5x. So what I'm going to do here, in order to differentiate this expression, rather this function, easily, I'm going to introduce ln on both sides. So I'm going to introduce ln on both sides. So according to the properties of logarithms, we know that this 5x can go down there. So we're going to have ln y being equal to 5x ln 6. So we can see now that it's easier now for us to differentiate this. And you can see that this is a product of two functions. We have ln 6 and we also have x this side. I mean 5x. So this side, when you differentiate ln y, you are going to have y prime. We know that when you're differentiating a function of ln, you do what? You differentiate the function, which gives you y prime, and then divide by the original function, which is y. So this is equal to the product here. We differentiate this with respect to x. We are going to use product rule. So we first reserve this 5x. That 5x multiplied by the derivative of ln x. Ln x is just a number. I mean, ln 6. Ln 6 is just a number. So the derivative of any number is 0. And then you say plus plus you reserve ln 6, then multiplied by the derivative of 5x there, you get 5x. Sorry, you just get 5. The derivative of 5x will just give you 5. So when you multiply that, you're going to have y prime over y being equal to, this will give you 0. 5x times 0, you get 0. And then this is going to give you 5 ln 6. You're going to get 5 ln 6. So y prime is equal to, you just take this y this side. So y prime is equal to that. So it's going to be 5 times y, you get 5y ln, you get 5y ln 6. So while there is y here, we're just going to replace with f of x. And then, so we're going to have y prime. I mean, we're going to have, while there is y, we replace with f of x. So we're going to have f of x prime is equal to 5. While there is y, we replace with f of x. But we know that our f of x in this case is just that. So our f of x is 6. This is multiplication. You multiply this, or let me just put it in brackets. 5 times 6 to the power 5x. And then you close the bracket like that. And then you write your ln 6 this side. So this is the final answer. So same applies to this question here. You also do it the same way, but in this case you are going to use the product rule. Since you are multiplying two functions, we have this function and this other function. So we are going to use product rule. So we proceed. So we have f of x is equal to, okay, let me answer this and this one, and then we'll come back to this one. Since at least you've seen how I answered this one, just in case time finishes first, let me first answer this and this. So here we can, yeah, we have f of x being equal to this. We can see that these two functions are dividing themselves. So since they are dividing themselves, we can use quotient rule. So what you do when you're using quotient rule, you identify your u and your v. So my u is equal to e to the power the root of x, and then my v is equal to the root of x. So what you do to find e prime, or let me rewrite this. So this is just the same as e to the power x, and then this x is raised to power half. This third, or the square root, is just the same as 1 over 2. Same applies to v. V can also be written as x raised to power half. So to find our u prime, we're going to have, our u prime is going to give us, you differentiate the power there, you are going to get, when you differentiate the power, you are going to get 1 over 2 x to the power half minus 1, you get negative half, like that. Then you repeat the same function, e to the power x to the power half. Okay, so we also differentiate our v to find v prime. So v prime is going to be equal to half, you multiply that power half to the, you multiply it with this coefficient 1 there, which is going to give you half times x. Half minus 1, you get negative 1 over 2. You get negative 1 over 2 like that. So just remaining with 10 minutes. So from here, we can now use our quotient rule. So our quotient rule now is going to be to find f prime of x. We're going to have v, my v is just the root of x, and then multiply it with u prime. U prime is this. So u prime can also be written as 1 over 2 root x multiplied by e to the power x. I've just replaced with the x to the power half with the square root of x. And then you say minus, my v is the root of x multiplied by, my u supposed to be here, I'm supposed to write u. So my u is e to the power root x, then multiply it with v prime, which is 1 over 2 root x, then divide everything by v squared. So v squared is just the root of x squared. So you can see that this can be simplified to e to the power root x over 2, then minus this is just going to be e to the power the root of x over,
Mr.
hello?
Yes, there minus v prime. Haven't you left root of x multiplying root of x at the far end?
Repeat your question.
I'm saying here where you're subtracting v prime, isn't it supposed to be half
Yeah.
root of x multiplying root of x?
The root of x is here.
Yes, what's v prime?
V prime is here. So I've just changed this x to the power negative half to this. I hope you've gotten it.
All right, I left the negative.
Oh yeah. So this is what we're going to have, and then this is going to be over 2 root x. Then everything divided by, when you square that, you're just going to have x. So you can also simplify this further. It can be simplified further than this, yeah, rather than leaving it like this. So let's do the last question here. If possible, I'm going to also show you how to do this one. So the last question there is cos e to the power 3x. So f of x, so in short, f prime of x, okay, let me write the question. So f of x is equal to cos e to the power 3x. So in short, if you remember what we did when you're differentiating trig ratios, so this is not supposed to be prime. This is the original function. So f prime of x is going to be equal to, f prime of x is going to be equal to, you differentiate your theta here. So our theta is e to the power 3x. So when you differentiate that, you get 3 e to the power 3x, and then you multiply it with the derivative of that trig ratio. So the derivative of cos x, we know that it's negative sine x. So our x or our theta there is just e to the power 3x. So you just simplify it as negative 3 e to the power 3x, and then multiplied by sine e to the power 3x. So this is n. Okay. So this is the derivative for the last question there. Now let me solve this one quickly in this just remaining 4 minutes so that we don't leave any questions here. So this question, as I earlier on said, since we are multiplying two functions, means that we're going to use product rule. So what we're going to say is, we're going to say let y be equal to this same function, which is 2x squared and times 5x minus 2. So here your u can be any of the two. So my u here I've chosen it to be x squared, 2 to the power x squared.
Mr. Teddy.
Yeah.
Oh, I thought f we were supposed to use product rule on f on on h, since there's cos or since there's cos and there's e to the power 3x.
No, this e to the power 3x is just the theta. Cos does not move alone. In short, trig ratios do not move alone without an angle. There's always supposed to be an angle. So this cos cannot just move as cos. It's supposed to have an angle. And the angle here that we have is e to the power 3x. And the way you differentiate this, you first differentiate the angle here.
Oh, okay.
Yeah, and then multiply with the derivative of the cos there. Okay.
But if it was cos,
What? If it was what? All right. So our v here will be equal to 5x minus 2. So find the derivative of this. You are going to have, you're going to introduce ln this side. You also introduce ln that side. So you differentiate this, you're going to have u over u prime over u being equal to, when you differentiate this, I mean when you interchange this, so let me just interchange them in advance. This is going to be ln u is going to be equal to, so this will be x squared ln, this is going to be x squared ln 2. So here, what you do is you differentiate this side, you're going to have u prime over u being equal to, you differentiate x squared multiplied by that, you're going to have 2x ln 2. Of course, when you differentiate this multiplied by that, you get a 0. So this is going to be your solution. Then you say u prime will be nothing but equal to u, I mean you multiply this u times this side. So you're going to have, yeah, you're going to multiply this u times everything this side. You're going to have 2ux ln 2. So what is u here? We know that our u was just equal to, our u initially was just equal to this, was just equal to 2 to the power, I mean, yeah, 2 to the power x squared. So our u prime will now be equal to 2, what is u, I'm going to put 2 to the power x squared, and then times x ln 2. So let us also find v prime. So to find v prime, we also have to introduce ln on both sides of this expression. So ln is equal to that, and then this side you also have ln 5x minus 2. Then you drop the power this side, so you're going to have ln, you're going to have ln v being equal to x minus 2, then ln x minus 2 ln 5. So we find the derivative of ln v is going to be v prime over v being equal to, we find the derivative of this, so a product, so we just differentiate this, then multiply it by ln 5. So meaning you're going to have, when you differentiate this part here, you can see that this 2 is a constant, meaning it will be a 0, but this x will be a 1. So I'm just going to have 1 multiplied by ln 5. So your v prime will be equal to v times ln 5. But we know that our v is just this part here. So we write our v prime to be equal to 5 to the power x minus 2, and then ln 5. Now, since we know that the question, this question here is a product of two functions, so meaning we're going to insert what we have found in the product rule, expression. So the product rule expression states that let me just write it here. We know that it states that V times U prime, here there's a plus, then U times V prime. For the product rule, there is no restrictions on the arrangement of V and U. But when you're dealing with the quotient rule, V is always supposed to start. And then minus U, and then V prime. So our V here is 5 raised to power x minus 2, which is just this part here. This is our V. And then V multiplied by U prime. So U prime is just this part here, which is 2x. And then we have 2x multiplied by 2 to the power x squared. Then we have ln 2. Then you say plus, this plus there, and then you're going to have u. My u is 2x squared, then multiplied by my v prime is just this part here, which is 5x minus 2 ln 5. Yeah, so if you want, you can simplify this by factorizing what is common there. So I can see that, so what I'm finding here is v prime, I mean f prime. So from just observing that, we can see that the common numbers there are, or the common terms there are 2x squared and 5 to the power x minus 2. They are common. And then you just open brackets and then write the remaining things, which is 2x ln 2. Then this side, you're just going to remain with ln 5. So this then is your final answer for this question. So you guys, this is the end of today's lesson. Since you're having a quiz, I want to leave time for you to go through chemistry as well. So tomorrow we're going to start with question 7 and finish question 8. Right. So I'm going to send the video as soon as I finish editing it.